Hi, my name is Christina Wongan, and this is my Lab 5 Choose Your Own Adventure. The purpose of this lab was to examine an inelastic collision of two toy cars, one moving and colliding with another stationary car. My objective was to compare the observed motion to the predicted model that I coded in VPython and analyze the momentum change and energy change. My results show that there was a loss in kinetic energy and momentum was conserved. The physics principles I used in this lab were 1. The energy principle, and 2. The momentum principle. The energy principle used for maximally inelastic collisions is that the change in energy is 0 and is equal to the work plus internal energy. Therefore, the initial kinetic energy is not equal to the final kinetic energies because there is also a change in internal energy. To calculate the change in internal energy, it is the initial kinetic energy from the system minus the final kinetic energy. The momentum principle is the change in momentum is equal to the net force times the change in time. However, during collision, the net force is equal to 0, and therefore the change in momentum is also 0, so momentum is conserved. First, I uploaded my video to Tracker of the two cars colliding. I set the origin to where the blue car started and plotted 3 different point masses. One of the blue car throughout the entire video, the second of the red car throughout the entire video, and then the 2 of the cars after the collision. Each of the graphs are plotted of position versus time, and you can easily see, based on the graphs, of where the collision occurred. I then took the data of the 3 different data points and graphed them to compare. Then I wrote a Python code for the model prediction. I created 2 spheres to represent the 2 cars, the blue ball as the blue car and the yellow for the red car. I then entered in the masses that was given to me on the YouTube video. I then entered in both ball velocities that I calculated based on the position data from Tracker. I then used the formula for kinetic energy to calculate the initial kinetic energy of the system before the collision, which is 1/2 the mass of car 1 times car 1 velocity squared plus 1/2 mass of car 2 times car 2 velocity squared. And then I calculated the initial momentum for the equation of mass of ball 1 times the velocity of ball 1 plus the mass of ball 2 times the velocity of ball 2. Then I created a while loop for the time before the collision to update the position of the first ball using the equation of the ball position equals the ball position plus velocity times change in time. And then the second while loop is the time after the collision, and I use the new velocities from the position data and use the same equations again to update their positions. Then to calculate the final momentum, I took both of the masses times the new velocity after the equation. And the change in momentum is just the final momentum minus the initial momentum. Also, I calculated the final kinetic energy by taking 1/2 of both the masses times the new velocity squared, and then change of internal energy is just the initial kinetic energy minus the final. I then ran the code and got the simulation. This is all my work that I used in my code. From the computational model, I found that the actual velocity should be 0.339 meters per second, but it was actually 0.35 meters per second. Therefore, there are some sources of error that could be due to the tracking video or because of friction. Also, the computational model has a loss of kinetic energy of 0.029 joules, but from observed, it only lost 0.019 joules.